The basic principle of the model is water balancing. Then this is the demand priority set as per the national water policy, that is environmental flow followed by domestic demand, then irrigation demand. Then the input to the WEAP model include the available water, that is given in terms of monthly data after allocating 25% of it to meet the environmental flow requirement. Then domestic water demand at a rate of 135 LPCD and the estimated population of each sub-basin. Then the irrigation demand and monthly variation in irrigation water requirements. And the 13 subbasins, the modeling of 13 subbasins was done, and also the total available water and total required water for each subbasin was plotted, and the demand coverage rate showing the percentage of requirement met is generated using the model to identify the subbasin that is having the water shortages. And to the result and discussion, this is the result and discussion result obtained from the WEAP model for subbasin 1, 2, 3, and 30. This is the volume of water versus that is available and demand curve is plotted. Firstly, then the demand coverage rate versus time. The similar procedure is done for all the 13 subbasins. And in the graph plotted with volume of water versus time, if the water availability curve is below water demand curve, that indicates there is a water scarcity in that particular subbasin. And if the demand coverage rate was time graph gives the percentage of requirement met in each month. And if the demand is fully met throughout the year, it is represented by a horizontal line with a 100% demand coverage rate, as in the case of this subbasin 1. And then an average demand coverage rate of summer months, that is from January to May, of all the 13 subbasins was plotted. And this was the result update. And based on this graph, the water scarcity, the result of the graph shows that out of the 13 subbasins of Kundipura, 6 basins are totally free from water scarcity problem since the demand covering rate is 100%. Then out of the remaining subbasins, 2 comes under severely stressed since the demand covering rate is less than 60%. Then 2 under moderately stressed, that is having a demand covering rate between 60 and 75%, and 3 under very lowly stressed, having a demand covering rate greater than 75%. And based on this result obtained, the water scarcity map of Kundipura was prepared, showing this is a scarcity. Moving on to the conclusion, the discharge of all the 13 subbasins were simulated by using the SWAT model. The CropVat 8.0 software was efficient in computing the irrigation water requirement for different crops of all the subbasins. The study then attempted to apply the WEAP model to access the water stress subbasin within the Kundipura River Basin by allocating the available water for various demands. The model was successful in identifying the water scarce subbasin by plotting the demand covering rate. And out of 13 subbasins of Kundipura, 2 comes under severely stressed, 2 under moderately stressed, and 3 under very lowly stressed region. Addressing the problem of using limited water resources available to meet the increased demand is a key issue that we need to resolve in these identified areas. These are all my references. Thank you.
The session is open for questions for the chairs.
Okay, hello.
Hello, sir.
Hello, Ms. Neetu. Okay, you had presented your work on identification of the water scarce regions in the Kundipura River Basin. This is a sub-basin of Bharatapuzha, is it?
Yes, sir. Yes, sir.
Okay. So, many years how much years is there?
Sir, for this study I've taken only 1 year. That is for 2003.
For
the calibration,
and you have taken only one particular year, 2003.
Yes, sir. That 13 or 14 years, sir.
Yes, but
Yes, and out of that, only 1 year that I was selected for the study, sir. The most worst year, that is the lowest average discharge giving year that I was selected for simulating the discharge in SWAT, sir. That is only.
so that is the year 2003, critical year.
Yes,
which
sir.
you are in.
Yes, sir. Yes. Yes, sir.
So what are your assumptions in your study? So now you have mentioned that you have taken only a critical year. Can you say what your assumptions are there in your study? Because you have not specifically mentioned any specific assumptions.
Yes, sir. First assumption that the available water that I've only considered the surface water. No other water is considered as available water. Then the demand also the major two demand sectors, that is the domestic and irrigation sectors, and also the environmental flow. That three are considered. Yes, sir. That are the major assumptions that I have taken.
Okay. So when you are going for these assessments, what is the time period you have taken for the assessment? That is for domestic assessment, then similarly irrigation assessment, all these things. That frequency of working out these demands and all those things. Is it on a what time domain?
Sir, that I've only the present condition only that I have taken that. Sir,
No.
2000 is
No, I am saying whether you are gone on a monthly scale or a daily
monthly scale, sir. Monthly scale.
Monthly scale. All these.
Yes, sir. Monthly scale.
For irrigation water as well as domestic water.
Yes, sir. Yes, sir. Sir, domestic that is per capita demand, that is 135 per day, and irrigation that is simulated in Cropet for a monthly basis, sir.
Okay, then the criteria for assessing the demand is you have mentioned demand coverage rate or something you have mentioned.
Yes, sir. Demand covering rate.
So the temporal variation of that demand coverage rate, how you have taken into that? It is only for the first 6 months. It is not for only for the 6 months it is available. Other months it is not available.
Sir, other months it is fully met, sir. That is the summer months. That is from January to May. That only there is a reduction in the demand covering rate. All other months the demand is fully met, sir. That is 100% demand covering rate. So that I have not considered that. The first 6 months only I have considered.
Then the other one classification which you have used that the criteria for identifying that is severely stressed
Yes,
or
sir.
moderately stressed.
Yes,
like
sir.
that. So
Yes.
is there any reference which you have used or you arbitrarily you have given?
Yes, sir. I have selected, sir. Rather than simply classifying the basins into water stressed and water stress free, I thought it is more realistic to represent based on the obtained result that I have classified it, not based on any standard, sir.
Okay, there is no, or why don't you look into the literature and say?
Sir, it's not based on the demand covering rate. I have based on the demand covering rate. I have not found such standards, sir. So that based on the obtained result, I have made a classification. That's all, sir.
Okay. What is the reliability of your study, or how far your study is reliable? Can you say anything?
Sir, actually, I have a second part. This is the first part of my project. The second part is I'm suggesting some management practices for this vulnerable area, sir. For that, I need to identify the basins with water scarcity. The next part that I'm suggesting some best management practices based on the land uses existing, like drip irrigation, sprinkler, and incorporating that in the deep modeling, and suggesting some of them for the reduction of this water scarcity issues, sir.
And one more thing, is there any storage structures available in this basin or diversion structure?
Sir, I have not considered that value, sir.
That is why I have asked you what are the assumptions in your study.
Sorry, sir. Sir,
anything.
yes, sir. Yes, sir.
Then what may be the reason? Can you say what may be the reason for suggesting the river basin 2 as the severely stressed? What is the reason actually? Is there anything which physically what may be the reason?
Sir, as there is no more populated area, I believe. More population, and also there is irrigation requirement also is there very more there. That's the basins.
The basin.
Yes, sir. I believe.
But you have considered a constant. What is the way in which you have considered the irrigation requirement? Have you considered the same constant irrigation area and like that you have worked out from the starting, or you have taken that variations which has occurred over the years?
No, sir.
You are taking only base year 2003, I think.
Yes, sir. Yes, sir. Yes, sir. Only 2003.
So that is another major drawback of your study. You cannot also just say for a project like this, you cannot say that only 1 year I have taken it and based on that I am giving this suggestion. You have to take long time and you have to see that if there is only 1 year,
Sir,
then you will never.
2003 is found to be the worst year, sir. So that.
Okay. But what about the other years then? You have done for other years, you can see that this problem may not be there or the magnitude
Yes,
will be very less.
Yes, sir. Might be.
Okay. Professor Suma, you can ask.
Okay, sir. Thank you, sir.
Thank you, sir.
have some So, have you validated this model?
Ma'am, beep model?
Yes.
No, ma'am. Validation is not done.
Because these areas are nearby this Vishnupuram and other places.
Yes, sir. Ma'am, the result is validated. When I've checked that subbasin with water scarcity, there are areas within that vulnerable areas, water scarce areas are there. By that, I have.
One more thing. Actually, this warm-up period is necessary before this training and calibrating the model.
Ma'am, not clear.
You have mentioned about this warm-up period for 3 years.
Yes, ma'am.
Before
Yes, ma'am.
calibrating the model. Is it necessary that this warm-up period to be given before this training and calibration?
Yes, ma'am. In order to check the I think it is necessary, ma'am. Mama period.
So can you justify? Because sometimes now the data is not available. Now you have divided the total period that is available into 3 divisions. Okay.
Yes, ma'am.
So is it
Only first 3 years for first 3 years I have used for warm upping, ma'am. Since I have that data available with me. Hello, ma'am. Hello.
Is it compulsory? Hello. Is it compulsory to take that as this warm-up period? That's my question.
Ma'am, it is better to take. I think, ma'am, if the data is available. Hello.
And so you have considered the demand as irrigation and domestic demand. You have considered the demand as this irrigation and this domestic demand. Okay.
Yes, ma'am.
And
Yes,
you have mentioned that from January to May, that is the most scarcity period that you observed. Because
yes, ma'am.
During the other periods, this demand curve that is coming below the available. That was
yes,
your
ma'am.
justification.
Yes, ma'am. Yes, ma'am.
So actually that is for 1 year, or have you checked? So normally this climatic changes there, and so that means this is shifting. That is summer season, and it is extending. Like normally nowadays the period that
yes,
we are
ma'am.
getting the rainfall is very less compared to the.
Hello. Hello, ma'am.
Earlier cases. Okay.
Hello.
So the seasonal change in demand, how will you account that? Either you account. Hello. Am I audible?
Hello, ma'am. Yes, ma'am. Yes, ma'am. Hello. Hello, ma'am. Hello.
Hello.
Ma'am. Am I?
There's a small delay in Sumaman's audio.
Have you accounted this seasonal change in? Is it audible now?
No, no, ma'am. Some not clear, ma'am. Question is not clear for me, ma'am.
Okay. Have you accounted the seasonal change that is occurring?
No, ma'am. It's a general trend that is from January to May. In that, and this is the worst case also, ma'am. 2003 is the worst water stress year too. And
How come you that 2003 is the worst case? Have you plotted the temperature or any other climatic factors?
And no, ma'am, it's also from previous studies, and also by considering the discharge of 2003, it is found that 2000 means discharge of these years. It is found that 2003 is the lowest discharge producing year. That's why I've chosen. No other climatic is not considered, ma'am.
Just like that, you have taken 2003 as the most drought year.
Vulnerable year, yes, ma'am.
Okay, then the other thing is that qualitatively you are classifying the scarcity as moderate and etc.
Yes, ma'am.
Okay, at
Yes,
that
ma'am.
end.
Yes, ma'am.
So how come you arrived? How do you classify that?
Ma'am, as I said to sir, it's not based on any standard. Rather than simply classifying it into water stress and water stress free, it is better to classify it based on the result that I have obtained. I have made a classification like that, ma'am. It's not based on any standard.
Okay. Okay, Neetu.
Thank you, ma'am.
Hello. Over to you.
Thank you, ma'am.
Thank you, Neetu.
Ma'am, hello. Thank you.
We'll be moving on to our next presenter. Our next presenter is Ms. Sharja P. Yusuf, paper ID 394.
Let me interfere 1 minute. Before you go proceed, you have to ask the audience also. Any other person wants to have a query. Whenever
Sorry.
one
Yes, sir.
person present it, you have to also ask the other audience. It is not that only the chair and co-chair ask the question. Others also may have clarifications to be sought. Okay, just ask.
Okay, sir. The session is open
Any
for
questions
questions
from
from the audience. So can we move on to the next presentation?
You can move. You can move. You can move. I think nobody is asking the question.
Okay. Our next presenter is Ms. Sharja P. Yusuf, paper ID 394.
Hello, good afternoon, everyone. Should I put the presentation?
Yes, you'll have to share your presentation.
Okay.
Sorry to interrupt. Ms.
I am not
Sharja,
able to. I am also not able to hear.
Ms. Sharja, your audio is off. Hello.
Hello? Yeah. Hello?
Yes, Ms. Sharja.
Yeah, tell me, please.
Yeah, now it is clear.
Your audio is not audible in the video that you have presented. So if you could stop
Yeah.
sharing your screen, we'll play the pre-recorded video
Okay.
from here.
Okay. Thank you. A very good day to one and all present over here. I'm here to present my topic on the ICE Test 2020 under the heading Seaside 2020. My paper ID is 394, and the topic is delineation of water bodies from Sentinel to MSI imagery. It's a comparative study. Myself, Sharja P. Yusuf Ali, and the topic is co-authored by Dr. N. Saji Kumar of Government Engineering College, Thrissur. Coming to the introduction, delineation is process of separating water bodies from the land pixels, and satellite remote sensing has been widely used for this. It helps us to get a synoptic view of the water bodies and an easier way of assessing the extent of water bodies. Traditionally, supervised and unsupervised classification has been used for this, and also the imageries from the DEMS or DEM has been used. Now, the supervised and unsupervised classification requires a thorough information of the various spectral classes of water, and the presence of different components or constituents in the water varies the spectral classes and complicates the issues. And there are spectral indices which separates water pixels from the land bodies from based on thresholds at bands, band ratios, or also by normalized difference methods. Now, there are atmospheric correction algorithms which are specifically intended for water bodies, which extracts the water pixels and then applies the algorithms on that. Coming to the objective of my study is to compare the water pixels extracted by these indices, that is NDWI, MNDWI, and SNN, which are the widely used indices, and the atmospheric correction, the water pixels extracted by the atmospheric correction algorithms, C2RCC and Accolite. Coming to the methodologies, the area of study is the northern area of the Vembanad Lake, that is Kochi Kyle, which is shown on the right-hand side, and the satellite imagery, it is Sentinel-2 imageries, which are commissioned by the European Space Agencies around in 2015, and the Sentinel images has got better spatial and spectral resolution. It's got 13 bands and the spatial resolution of 10 meters for the visible bands, and the radiometric resolution is also better. Now, the software that is used for processing is Snap Surface, which is again developed by the ESA itself. Now, the water extraction indices that are used are NDWI, MNDWI, and SNN, and which is explained in the next slide. The atmospheric correction processes that are used are C2RCC, which is based on a neural network, and Accolite, which is based on Accolite, and CentOCore, which are based on a set of algorithms for the removal of atmospheric interference. Coming to the methodology, the input data that is available from Sentinel-2, I'm using the level 1 imageries, which provides a top of atmosphere reflectance. The images are processed using the Snap software. They are corrected and reprojected, and then applied. The atmospheric correction is applied using the 3 algorithms. Now, the C2RCC and Accolite provides water pixels directly in the processed images, only the water pixels in the processed image, while CentOCore is basically meant for land pixels, and so it does not extract the water pixels. And I've used Sentinel reflectances or reflectance values for the indices because the L2 image that is correct, that is a product of Sentinel, the ESA, is corrected by CentOCore, and so hence I've used an equivalent correction algorithm for applying the various indices. Now, coming to the water extraction indices, the basic theory of water extraction indices is that the water has high reflectance in the green band and very low reflectance as it moves towards a higher wavelength. And NIR has got the first NDWI index. It finds a normalized difference between the green and the NIR band, and the modified normalized difference water index, it uses the SWR band or the shortwave infrared band, which moves further ahead. Now, the SNN, which is a combination of 3 algorithms, that is a sum 457, that is the sum of the NIR and the SWR bands. The normalized difference between 5723, that is the SWR bands and green and red bands, and the normalized difference between 571, that is the SWR bands and the blue band, and the threshold values are as shown in the figure. Now, coming to the results and discussion. Now, these are the water pixels extracted by the algorithms, by the atmospheric correction algorithms and the indices. The first one, which shown over here, it is the water pixels extracted by C2RCC. C2RCC is basically it's based on neural network, which is from a data set of about 5 million values, and so it does not require any prior study of the area or any modification of the default values. Now, the second one, observing the first image, it is pretty clear that all the narrow streams are also fine narrow streams are well extracted in the image. Now, the second image is of that of Accolite with the default value, and Accolite, it separates a water pixel based on a threshold value of 0.0215 at 1600, that is the shortwave band. And the value above this 0.0125 is considered as land pixels, and it is extracted out, or it is masked out, removed removed from the water pixels. Now, assessing the spectrum, I found out that the reflectance in these bands are greater, and so I've applied a value of 0.06 for the threshold, and this helped in better extraction capability for the Accolite. Now, coming to the fourth image, that is applying the NDWI index for the NDWI index. This is the image, and it shows that the fine streams are masked out, and MNDWI and SNN gives a better value, or gives better results, gives better water extraction capability, even though the streams are fragmented. Now, coming to the next part of my study, that is comparing the seasonal variation. Since from the first slide, it is pretty much clear that C2RCC gave a better result, and so I use C2RCC for extracting the water pixels from two other images of the same year, that is one in October and another in March. This is the three images, FCC images of the three dates, and this clearly shows that the first image, which is of October, it has got dry patches in various areas, or you can see the water pixels excluded from various areas, which are marked in red. And the reason for this has to be investigated because the satellite imagery of these areas could not be obtained because of unclarity, foggy days on these days. Now, coming to the inference about the seasonal variations, FCC image of October, as explained, it showed significant variations from the two imageries, and many of the streams have narrowed down and become feeble. Several dry patches have been visible, but the reason for this behavior after a heavy monsoon in August needs to be investigated. Now, observing the temporal variations in the delineated map gives us an indication on the fluctuations in the extent of water body. Now, coming to the conclusions, NDWI showed a very poor performance compared to all the other methods, and all the narrow streams were excluded from water pixels. SNN and MNWI performed better. The SWR, or the shortwave infrared bands, were better suitable for delineating turbid and inland water bodies. The presence of turbidity reduces the efficiencies of the indices values, and the C2RCC proved the robust method, which did not require any prior knowledge of the area, since it was based on ANN. And Accolite could also showed a better delineation capability once the threshold value was appropriately modified. Now, the choice of the algorithm, it requires prior knowledge of the optical status and the physical status of the area of study for getting accurate results for the water area. And observing the temporal variations is pretty much easier using delineation by satellite imageries, and gives us a quick indications on the fluctuations in the extent of water body and its seasonal impacts. These are my references, and thank you.
This session is open for questions from the chairs.
Okay. Hello, Mr. Arja?
Yes, sir.
Okay. I think you had given an overview of your study. It is actually delineating the water body, that is water pixels from the satellite imagery. Is it the?
Yes, sir.
Okay. So you were by starting, you had mentioned that we have supervised and unsupervised algorithms like that. So what type of algorithm is which is the one which you have used here?
Neither of them, sir. This is not supervised or unsupervised. We have applied the reflectance in particular bands for finding out the water pixels.
So that means
It's spectral indices.
only indices you have used, because initially you have mentioned you have C2 RCC, then acrolite, then Sen2 corp, like that you are mentioning that you had.
Yeah.
Is
C2
is it the algorithm that is used for extracting C2 RCC, whether it is an algorithm?
C2RCC and Accolite are atmospheric correction processes, algorithms, set of algorithms.
Oh, it is only for atmospheric corrections which you have used.
Yeah.
And so you have used only MDWI and MLDWI. So will you go to your that slide? Can that slide be shown? Will that slide be shown? Because I felt
Should I go to the slide or?
anyone, just for clarity.
Okay, I'll just present it.
Could you please present the slide?
Okay.
Maybe slide number 5 or 3, like that. I do not.
1 second. Slide number 3, sir.
Yes, just saying that I think that flowchart, some flowchart you are showing that. Yes, I think that's not. Yes, this one. But what is the meaning? This is atmospheric perspective. But what is the meaning here? What is the meaning of this? You have given Sentinel-2 images, then the atmospheric corrections you are mentioning. After here directly you are mentioning water pixels. Are you getting directly water pixels after that correction to atmospheric process?
Yes, sir. Yes, sir. That is what. So these two processes, that is C2RCC and Accolite, that are meant for water pixels. That is meant for water pixels, and the algorithm is specifically for that. So what it does not do the correction for the other pixels, or it removes out all the other land pixels, and only the water pixels are extracted. So that is one benefit of these two, C2RCC and Accolite. So that is why, and then later on, the atmospheric correction.
Can we say that this is an unsupervised algorithm? Even though it is an atmospheric correction, can we say it is an unsupervised algorithm? Because what data you have to give here? Whether you require any data to be given, that is the one which I want to know.
Actually, sir, I'll tell you how this it's unsupervised algorithm is. Basically, you are considering only the spectral reflectance, and then you are dividing it into classes.
Yes.
And, and this C2RCC, how it does is it uses two values. And a set of values are, one is the inherent optical properties like absorption, scattering of the various components, and the total absorptions, etc. All those are on one side as the input, and on the output you have the various reflectance that you get if the water has all these components, constituents. So that is how it has got about, say, 5 million values of data set, and it is from the studies conducted on various oceans and inland bodies. And also there are simulated values from what you call softwares like Hydrolite simulated. You get the simulated reflectances and the corresponding IOPs. So this is how it basically does. C2RCC, you get the values of absorptions and scattering coefficients, scattering of the constituents, plus what is the related reflectance, total reflectance of this. So that is how they relate it. And Accolite, how it does is it uses for the atmospheric Rayleigh correction is Rayleigh scattering is correction is done, and then the aerosol collection is done by another algorithm, and after this they are processing it for the water pixels. What they're doing is they're using the reflectance in 1600 nanometer, that is the SWR wavelength, and above a particular default value they've considered that one particular value, and above this it's considered as non-water pixel, because the water has negligible reflectance in the SWR band. That is the basic theorem. And coming to the
whether any thresholding principle has been made use of?
Pardon, sir?
Thresholding principles.
Yeah. For acolyte, you're talking about acolyte?
No, anything. Is Acolyte or C2RCC or anywhere.
C2RCC, we don't have any control over that because it just uses the ANN principle. So we don't have any control of the values. So once you put the input value based on the ANN, you get the result.
So if it is ANN, then what type of algorithm of ANN is made use of there?
ANN, you are asking about the data set, right, sir?
No. There may be an algorithm. ANN means it is only a tool where it uses different types of algorithms for.
I haven't gone into the algorithm of that because this particular software or processor is there in the software, that is the SNAP software, which is given again by the ESA. So it has got the inbuilt algorithm which uses that is what they mentioned.
You should get that. You should get that. At least you should get the details of that algorithm which is being used. Even though you are using a software, that I agree. Okay, because software is self-tested by different persons. Okay, at different levels of complexity it might have been tested. It is not that you can say that it is just available there, so I made use of, I got the result like that. No. That is not a good way of commenting that one, at least because you are, whenever you use a software, at least you should know that what are the input algorithms which is being used. One thing.
Okay, sir.
And similarly for Apple, because you have not given any details of that in your presentation. That is why I was asking.
Yeah, yes, sir. Basically, because it was based on ANN, I didn't go deeper into that. I just looked what is the
even ANN also you have to say that what is the algorithm that has been used, one thing. Then what you have to say that is there any thing which you have to do from your own? That means any parameter.
Okay, for C2RCC, there are basically two options. One is the normal setting, and the other one is for the more complex settings. That is when the turbidity and the other constituents gives a very complex situations like higher turbidity. These are the two basic settings that we can modify in that particular algorithm.
We have to give any parameter values because like. Then. Is there any other than atmospheric correction process? Is there any pre-processing or anything which is to be done here, which you are doing here?
Just the basic pre-processing like resampling and reprojection. That's all. I do the reprojection, then resampling, and then the atmospheric correction.
So, what is but going to the result, just somewhere down here, making a comparison of that three. I think can you go to that slide where you are making this comparison? How you check the accuracy? How you check the accuracy of your result?
Accuracy, I've compared it with the satellite imagery. That's all that I could do.
How you can check directly with satellite imagery? It is only by visual. That is only
visually. Yes, visually. That's all.
When you go for image processing, you have to check the accuracy. You have to check the accuracy actually. After you process the image, you have to check it actually. Otherwise, how you are you believing that this whatever thing which you have got is correct or not?
From the visual image, you can see the streams. By zooming into the Google Images, you can see the streams. So once that streams are correct, that is just broadly I've just classified it. Because if you compare,
that means there is no misclassification. This is 100%. No misclassification. Can you say that there is no misclassification? Have you? Why don't you?
I cannot say that. I didn't do that. I didn't do that. Accuracy check was not done.
You should work out at least some of the coefficients. You should work out matrices, confusion matrices. Okay, then only the study will be acceptable.
Yes,
that's you have to, especially on this side. Unless you check your accuracy, people cannot actually. You cannot say that I have just visually checked it. That is not sufficient. You have to check it by means of statistical measures of accuracy.
Yes, sir. Yes, sir. That's true.
So try to improve that way. You try to improve it so that you will be, and also try to understand the algorithm as well as all those things also.
Yeah, okay.
You can use the software, whatever software it is available, that is okay, there is no problem. But understand what is happening inside.
So,
Basically, it was just the C2RCC. I just left like that. But other two algorithms, since algorithms are very clearly mentioned, I have a little bit of idea. But C2RCC is just very broadly mentioned that these are the data set that are used. So they haven't mentioned anything about the clearly about what type of ANN is used in that. So that is why.
Maybe there will be C2RCC. There will be a reference paper available for that.
Yes, sir.
When you look into that algorithm, you will be able to see that what is that detail.
Okay, sir. I'll just go deep into
That
that.
reference paper and you should see this. And then you will be able to understand.
Yes, sir. Yes, sir. I'll go deep into that.
Okay, so Professor Suma, you can.
Okay, thanks, sir. Sharja, I have one question. You have mentioned that turbidity that is causing the problem in detecting the or in differentiating the colors or pixels.
Yes, sir. Yes, ma'am.
Hello?
Yeah, yes, ma'am. Can you hear me?
Okay. Okay, so if this water surface now that is maybe
Ma'am, I can't hear you clearly.
this some algae or fungi that will be adding some color to the this water and it will be. Is it audible now?
Yeah, now it's okay, sir.
Hello?
Yeah, now it's audible. I
Yes,
didn't
okay.
hear the question
Okay.
actually.
Okay, suppose okay, then I will pause the video. Okay. Suppose the water surface is completely filled with then sometimes it will be adding the color to the water. So is it possible to differentiate the colors then? So is there any anything to be added to this your methodology to the situation to handle the situation like this?
Ma'am, you are asking whether there will be algae covered or the chlorophyll presence. I mean, this is depends, if it is algae or algae is vegetation. Since we have the atmosphere, you are taking the satellite imagery, you cannot detect it. Algae will be detected as vegetation itself, though it won't be detected as water. That is one demerit. You cannot understand it. It will have the same property. And another thing is, if it is the chlorophyll simply, that is the chlorophyll that is present in the water, it does not have much impact in the SWR range, and so you can use this algorithm itself.
Okay. Okay. So this is the only situation. This is the only demerits what you can expect when you are applying this methodology. Am I right?
So far, I mean, if you come into later on different cases, maybe there are different situations. I mean, so far in this situation, I think I have C2RCC showed the better result.
So among this C2RCC is the
C2RCC, like if you see from the image, C2RCC could detect the finer streams, but all the other images you can see the finer streams could not be correctly separated out. It is broken over here.
What about this MNDWI?
MNDWI is also good. It's also good, better, but still again, this area, the streams, it is a little bit. What you call narrow. I think it is narrow because they are just assumptions. I haven't done any ground truthing. It is all based on satellite imagery studies. I haven't done any ground truthing. The only reference I had was the Google images, and I'm comparing it with that.
Do you have any reference in connection with to compare some of the area of your percentage? Means
actually like what sir's the accuracy check you are talking about that?
Yes.
Accuracy check, that is what the only thing I verified is with the Google images. I just zoomed in the Google images and saw what are the areas in these areas. I mean, in this particular regions.
Is it possible to superimpose or something like that? That we are.
Yeah, you can do that, but I didn't try that. You can do that. You can superimpose it on the another images, and you can compare it. I haven't done that. That is a good option to compare it.
Okay, Sharja. Thank you.
Okay, thank you, ma'am.
Now the questions from the audience are expected? It is open to the questions from the audience.
Hello. Your concluding remark on the last page. Can you go to the concluding remark? Hello.
Yeah, yes, sir. Yes, sir. Can you see?
Hello.
Hello?
Okay. And which you have mentioned that the choice of the algorithm for water body delineation needs prior understanding of the physical and optical status of the area of study. What do you mean by that? Choice of the algorithms for the water body delineation needs prior understanding of the physical and optical status of the area of study. What do you mean?
Actually, what I mean by this is for this particular area, we have found that the water was turbid. And so the algorithms like NDW did not work. But in a clearer stream, it'll work well. So you have to know what, just a little bit of understanding of what is the water quality status, or not water quality, or the optical status means what is the color of that water. Is it turbid? Is it clear? At least the basic property, basically how it is. It is just a little bit of enough information, because once you use NDWI is a good index. Actually, it is a widely used index, but this is the problem with it. If you are using it on turbid streams, it will not give you the correct answer.
So, which algorithm is better in mixed pixel conditions, and how will you interpret or delineate in mixed pixel conditions? And which algorithm is better?
Mixed pixel condition means you are talking about a particular pixel which is mixed, or you have all the categories of water. That is the question. All categories of water is there. Means you have turbid, you have clear.
Yes,
Exactly.
yes.
Okay. That I prefer
Yes,
from
yes.
from my present study, and which I have done other areas also. I found that C2RCC is doing well in all types of water. I mean, it is doing well in water which has higher chlorophyll, and water with higher turbidity, or with clearer water, and for oceans also salinity. All this does not matter. And it is also a very good. I tried this because it proved. The atmospheric correction capability was proved well, but nobody looked into the water extraction capability of this algorithm, because that is, you have to see whether all the water pixels are extracted. Only then you can see whether the area we have under study is completely considered. That is one thing you have to analyze. So that is why I checked into this part. So I recommend a
How
C2.
that turbidity?
Pardon?
Okay. C2R. Okay. How the turbidity water which affect the reflectance? And
How the turbidity? Because the turbid water, it reflects there's a higher backscattering from the NIR area. There's a backscattering property of this the sediments or the turbid materials that are present in the water. It backscatters energy, backscatters spectrum from this NIR area. So this is one problem, and from the basic of this algorithms, what it does is you are assuming that the land and the other vegetations has high reflectance in the NIR and SWR area, and the water has negligible reflectance in the NIR and SWR areas. So when you get this, so that is the one cutoff that you're taking. That is, if the reflectance is above this particular limit, then it is considered as land and it is cut off. That is the basic threshold. So once there is turbidity, it starts reflecting from the water itself. It starts reflecting, and so the algorithm cannot identify it is from the land or the water, and so it cuts it off. That is the main problem of this turbidity.
Okay.
It starts getting the reflectance in this area increases.
Okay. Thank you. Okay.
Okay, sir. Thank you, sir.
Thank you.
Thank you, Ms. Sharja.
Thank you, ma'am.
We'll be moving on to the next presenter. Our next presenter is Ms. Setu Parvati, paper ID 300.
Good day, everybody. I'm Sethu Parvati, and I've completed my MTech in Water Resources and Hydroinformatics from Government Engineering College, Thrissur. The topic of my presentation is Impact of Urbanization on Flooding in Chalakudi River. Moving on to the introduction, we know that extreme events like floods cause destruction anywhere they occur. And one of the major contributing factors to this cause is urbanization, which affect the intensity as well as frequency of floods. The role of urbanization is such that it increases the impermeability of the area and hence increases the runoff. The Chalakudi River Basin was affected by an unprecedented flood during August 2018, and the area has undergone rapid urbanization, which has worsened the effect of flood. The objective of my thesis was to conduct a model study to assess the impact of urbanization in Chalakudi River Basin by comparing and analyzing the flood peaks for different land use scenarios. The data used for my study are DEM of the study area, rainfall data for the month of August for 2 years, that is 1995 and August 2018, the discharge data for the same duration, satellite images, land use map, and soil map. This figure shows the DEM of the study area, and the second figure shows the rain gauge station and the stream gauge station in the study area. Moving on to the methodology, the first step is to extract the digital elevation model or DEM of the study area so that a basin model can be created to perform the hydrologic modeling. Then the land use maps for the required years were created using ArcGIS and satellite images. The land use map of the year 1995 was available from Decadal and it was reclassified according to the requirements. But the land use map of the year 2018 was not available and hence it was created using ArcGIS. Once the land use land cover maps was obtained, the land use land cover change of the study area that has occurred over the past 2 decades, that is for a duration of 23 years from 1995 to 2018 was identified. Once this was identified, the change in land use and land cover, the effect of change in land use and land cover on the flood peak was determined using the HEC-HMS model. Now moving on to the detailed steps. In HEC-HMS modeling, the DEM of the study area is first extracted, then terrain pre-processing steps were carried out. Then the land use land cover maps were prepared and the 2018 land use land cover map was created by supervised classification in ArcGIS. Then the CN grids for both the land use land cover maps, that is of 1995 and 2018, was prepared. Then correspondingly, the basin files were also prepared for these 2 years. This figure shows the land use land cover map obtained from Decadal and the land use land cover map of 2018 which was created. This figure shows the creation of the table and the basin file output. Now for HEC-HMS modeling, the Muskingum routing was chosen, and for Muskingum routing, the parameters x and k were to be determined. The x value was taken as 0.25 and the k value was determined using the equation L by T, where velocity was determined by the Manning's equation. And for that, the cross-sectional details were obtained from HEC-CRAS and Google. Once the model was set up, then by providing daily rainfall values for the month of August for the years 1995 and 2018. Both the models were calibrated and validated to obtain the outlet hydrographs. Once calibration and validation of both the models was completed, the 2018 rainfall was then provided to the 1995 model to observe the change in the mean value. This shows the steps of calculation of K value. Moving on to the result and discussion. This table represents the land use change matrix, that is, represents the land use change from 1995 to 2018. And this table was represented in a simple form, assuming annual rate of change, assuming a uniform rate of change through the years. From this analysis, a drastic increase in the urban area, that is, by almost 70.5 kilometers square, can be identified in a span of 23 years. Now, the 2018 HMS model was calibrated using the August 2018 values. Similarly, validation was also carried out. The R-square values were obtained satisfactorily. Once the 2018 model was completed, 1995 model was also calibrated and validated in a similar manner. The R-square values were obtained satisfactorily, and once both the models were calibrated and validated, the 2018 rainfall was applied to the 1995 model to observe the change in the peak. And the result obtained was as such, that is, the peak value of the rainfall, peak value of the outlet discharge decreased by an amount of 22.69%. That is, when the 2018 rainfall was applied to the 1995 land use model, a reduction in peak by 22.69% was observed. Moving on to the conclusion, from the land use change matrix, a drastic increase in the urban area, that is, by 70.57 kilometers square, can be identified in a span of 23 years. Then, the 2018 flood was modeled using 1995 land use, and a decrease in peak by 22.69% was observed. The impact of the greatest flood in the last 100 years would have been reduced if the land use land cover has been maintained. Hence, the effect of urbanization on flood peak was studied. More than the rainfall, we can say that the rapid urbanization and the changing landscape for accommodating the human needs have definitely added oil to fire in the occurrence of such phenomena. And with the help of such studies, critical areas can be identified, and hence a well-planned infrastructure with adequate drainage facilities and flood control measures can be implemented to prevent such future occurrences. These are some of the main references that I've chosen for my study. Thank you.
Thank you, Ms. Sedu. Now the session is open for discussion.
Hello.
Yes, sir. Hello.
Hello, Ms. Sedu. You have carried out a study on the impact of urbanization on flooding in Chalakudi River basin.
Yes, sir.
Have you got any specific assumptions attached to your study?
Sir, assumption. The effect of reservoirs were not considered because the change was limited to land use. The study was limited to land use.
So that means reservoirs are not considered, but 2018 floods are you have large amount of contribution from the upstream reservoirs also.
Yes, sir. I have just studied the effect of change in urbanization. Due to change in urbanization, what will be the effect? That's all.
Yes. So that is the only thing. So that is the only assumption which you have. Okay. Then one thing from where you have got the land use land cover map?
Sir, the 1995 land use land cover map was obtained from Decadal.
The other one?
The other one was created, sir.
From where?
Using supervised classification in ArcGIS. The satellite image was downloaded, and then land use map was created.
So whether these two pertain to the same month or like that? Is it the data? Have you checked that?
Sir, the land use maps.
Land use map.
No, sir. Only the year can be said to be.
How can you justify that your land use is correct or not? Because when you have a seasonal change, even with a season itself, there is a wide change in the land use, even in a year, within a year itself.
Sir, basically the land use won't change that much within a year, sir.
There will not be any change. You say that there will not be anything.
No, sir, there will be no considerable change within a year.
If you are saying only urbanization, okay, maybe urbanization area, maybe there. Then
Yes,
another thing I saw from your table, actually, I think some. And another thing is, after doing the classification, have you done any accuracy assessment for that? Because any classification has to be given with some accuracy assessment.
No, sir.
No. What was prevented you? Because it is 2018, even 2018. You at least you should have done it with some Google image and like that.
Sir, the map was created in consultation with the Google Map and Google Maps.
Okay, you thought that it may be correct or not. Okay, let us take in that case. And the next thing is, I have seen that in that table which you are given, the forest percentage
Yes, sir.
has from 622 kilometers square, it has decreased to 451.
Yes, sir. Especially in the
How you check with this one? Whether this is the correct one? Because the destruction of the forest is close to about that is nearly 70%. 70% of the forest is existing in that area. So this is about very ahead of our standard average.
Sir, from the Google Maps, we can see that now it is identified as vegetative body.
Vegetative body you can identify, because whether my doubt is whether have you gone any misclassification, that is why I was asking. Have you gone for any misclassification? Because whenever we say something, because your thesis is a published document, even your this work is also a published document, somebody may take this one in future and say that Setu Parvati has reported in this work that this is the land use change. You have given a land use matrix and all these things, and that values have been given. So you should, before giving that type of details, you should check with some agencies or some things. It's not that you cannot say that I have done a classification, I have got the answer. That is not a very appropriate reasoning for that. Because any study has to be, it is not that you are doing a problem in the class, because whenever we go for study, some aspects has to be incorporated along with it. Okay, that is not. Then in this study also, how you have carried out that you have applied the same rainfall with a land use classification which is available at that particular site. Is it the way in which you have done it?
Sir, I didn't get you, Mr.
No. How you have made a comparison that the land use has an effect on this particular?
Yes, sir. The 2018 rainfall was applied to both the models. The same rainfall was applied.
Oh, 2018 rainfall again with the 1995 land use.
Yes, sir. Yes, sir.
Oh. Okay. So you think that the land use may be the major reason for only for this classification, for this type of flood which has occurred is only due to land use changes. Is there any other cause which we can resort to? Or,
Sir, one of the major reasons will be urbanization.
okay.
Sir.
So, but because one problem is whenever we have a modeling, when we go for modeling, because we are going for a calibration when you go for this parameter adjustment and like that. So it may be adjusted with respect to whatever land use which you will be giving. That is another thing is there. So we cannot 100%, we cannot say it may be 100% true like that. Maybe there's a chance that way only we can say. It's not that 100%, you cannot say that that is the only reason which has created this amount of change. Okay, thank you. Now, then one more thing I want to say is your conclusions, you have given so many general conclusions at the end. Instead of that, you try to resort to your specific conclusion.
Okay.
While presenting it. Okay, Professor Suman, we can ask.
Hello.
Hello, ma'am.
Hello, Setu.
Yes, ma'am.
Can you
Hello, ma'am.
show me the slide number 16? 16?
Yes, ma'am. Yes, ma'am.
Hello. Can you show me the slide number 16?
Yes, ma'am.
It's not coming.
Ma'am, there
He
is
has
a
to
slight
project
delay.
it. He has to project it actually.
Are you projecting?
Yes, ma'am. Yes, ma'am. Ma'am, can you see now?
Okay, it's coming.
Ma'am, slide number 16.
Okay, slide number 16. So actually, total period of your study, that is 23 years. Okay,
Yes,
starting
ma'am.
from 1995 to 2018. And you have selected to study the impact of urbanization. You have selected 2018 rainfall. Okay, agreed. Now, and you the land use change table what you are giving is represents the land use in 1995 and 2018.
Yes, ma'am.
Okay. Now, so in your results, I could see that 1995, and you just compared this 2000, means in 2018. Yeah.
Yes, ma'am.
So actually, the planning now normally 5 years or 10 years that will be taking place. That means whenever if you want to expand the area, it is planned for a period of 5 years or something like that. Okay. So,
Okay.
have you checked the intermediate stage? Because 1995 to 2018 means it's a long duration, long period. Okay, so that means which part that is organized that will be causing more that is causing more critical. That will be that should be a more critical part in creating this flood. So
Yes, ma'am.
normally, whenever we are expanding because it is not coming all of a sudden because all
Yes.
this change that coming over a period of 23 years. Okay, so when the change is coming one after the other, okay, sometimes no mind this long period in one stretch, you split this based on the expansion plan of this panchayat or this municipality, so that one could easily detect that which causes which change, which land use change will be the most critical that
Okay.
will be causing the flood in future also.
Yes, ma'am. I thought to bring to show the greatest impact. I thought to take such a great gap between the 2 years. That's why I took such a huge gap.
Yeah, because this whatever the change that is coming, it
Yes.
came for a period of over a period of 23 years. Okay,
Yes, ma'am.
so
Yes.
once this actually in this vegetation, if you are comparing the vegetation, this
Yes, ma'am.
vegetation part that is increased
Yes, ma'am.
in 2018, but
Yes, ma'am.
all other things. So vegetation means it's a paddy field or something like that. What happened? Because all other that is not giving that much impact. But when we are improving the vegetation means how come you can justify the fourth one?
Ma'am, I
Barren
didn't
land
get
increased, increased. Okay, forest area that is getting reduced, but vegetation part that is increased.
Yes, ma'am.
Okay, so is it? How come you can justify this? Because whenever we are increasing this vegetation, that means it is an impervious area only, no?
Yes, ma'am. But even though the vegetation has increased, the built-up
Not
area has also
impervious, sorry,
increased.
it is pervious, no? This improving vegetation, increasing vegetation means it is there is a chance of infiltration, or it will be
Yes, ma'am.
pervious. Okay,
Yes, ma'am. But compared to the other change, it is still small, ma'am.
so
That's
that is
why.
why I just want to check which change will be possible is most critical. Because
Okay.
your idea is to that if this urbanization or land use change, if it is if you are able to prevent to some extent, okay, then the
Yes,
chance
ma'am.
of occurrence of the flood that will be less.
Yes.
So that is why it is only suggestion because because you are having so much data with you.
Okay.
So instead of going directly by
Okay.
taking a long period of time, then you can identify that is which part or which change will be the most critical part that causes the flood.
Yes, ma'am.
Otherwise, so how will you justify? Are you okay? It's not connected with this. And as far as it's like sir mentioned, the conclusions what you are giving are the general conclusions only, not specific.
Okay.
So whenever when you are giving these conclusions, you should be careful for the.
Okay, okay, ma'am.
So that's all. Say it. Thank you. Now this question answer session is open to the audience.
Hello. Hello.
Yes,
Hello. What about your conclusion regarding the study on impact of urbanization on Chalakudi River Basin specifically? What is your conclusion? How will
Sir,
you
my
conclude?
yes, sir. Due to urbanization, there has been an impact on the flood peak.
No. I mean, on what percentage wise? Are you quantify in percentage?
Yes,
How
sir.
much
I
it will
told that in the
increase?
conclusion. Yes, sir. By 22.69%.
Okay. Then you have done it for the past, and if you want to, suppose if you want to predict it for the future, what do you
Yes,
do?
sir.
This,
Sir. Yes, sir.
what do you do?
Future land use predictions can be done.
How?
And with sir, I believe it was DAS software. Future land use predictions can be done.
No, what is that principle you have to use? Anything, time series, some predictions. Without that, how can you predict for the future, the land use, urbanization?
Sir, in my study, I have not predicted for the future.
Okay. You are not predicted for the future. Okay.
No, sir.
Okay. Thank you.
Thank you.
I hope there are no more questions. We'll be moving on to the next participant. Our next presenter is Miss Amrita TK, paper ID 325. Miss Amrita TK, we have a technical issue in playing the video here. So could you please share your PPT and do the live presentation?
Yes. Is it working?
Yes, it's visible and you're audible. You can start the presentation.
Okay. Good morning, all. Today, I would like to present about shoreline change detection at the Kodungalur Chetua region in Kerala state. Natural processes like
Sorry
erosion
to
and
interrupt.
accretion.
Amrita, could you please open the slide show?
Okay. Okay. Natural processes like erosion and accretion are the main source of the shoreline change, which can be in response to several short term events and long term events. The short term events are storm, regular wave action, tides, and winds, etc., whereas the long term events are orogenic cycles, etc., that can be significantly alter the sea level, coastal land subsidence, or emergence. Most of the coastal lines are naturally dynamic, and as a result of the rapid development of the economy and hazards, coastal erosion has become more and more serious. Moreover, negative environmental impact due to the anthropogenic activities like sand mining, overexploitation of the groundwater, and other indirect cause of the coastal line retreat. Coastal zone monitoring is an important task in the national development and environmental protection, in which extraction of the shoreline shall be regarded as the prime focus. Hence, it is important to prepare the shoreline map. My objective of the study are to prepare the shoreline map using ERDAS imaging and ArcGIS to determine the shoreline change occur in the last 2 decades at the Kodungalur Chetuva region using DSAS software, and also to identify the most vulnerable areas. This is my study area. Kodungalur Chetuva region in Thrissur district of Kerala state. It has a coastal length of 40 kilometer, and it is surrounded by the water bodies and all around as shown in figure. The west side of the area is bounded by Arabian Sea, the northeast region by Karuvennu River, which is shown in blue color, southeast region by Kanoli Canal in yellow color, and Periyar River with white color. The major places in the coastal stretch of the study area are Azhikodu, Pazhaya Bazar, Kara, etc. There are about 50 acres of land uncultivated due to the saline water intrusion in this area. In current scenario across the study area, many families from the critical location have been shifted to other places due to the erosion and accretion. The road system has also disputed in many places. Moving to methodology. The methodology elaborate by step-by-step procedure for detecting, analyzing, extracting, and quantifying the shoreline change in the study area. To extract the shoreline and to study its change, the Landsat MSS image of 97 and Landsat ETM Plus image of 2014 are downloaded from USGS Earth Explorer. The first step in this shoreline extraction by multispectral image pre-processing, the satellite imagery is georeferenced with the topographical map. The various pre-processing techniques used are haze reduction, noise removal, de-stripping, focal analysis, histogram equalization, brightness inversion, etc. Haze reduction is increase the image sharpens, and thus it is important to remove it from the image. Image may also have cloud which mask the actual information. Clouds seen on the shoreline are removed by adding holes in the image while mosaicing. Thus, if clouds are found in the shoreline area, such images are mosaiced using most recent cloud-free imagery. De-stripping and focal analysis tools in ERDAS to remove the black strip in the image taken in SLC off mode. Extraction of the shoreline need better visibility of land-water separation. Hence, for distinct land-water separation, a supervised classification is done on pre-processed image. These are the images. The second one is the screenshot of pre-processing of Landsat image of study area using ERDAS imaging software. Third one is the subset image of the study area. In this study, the shoreline is extracted from the pre-processed image using ArcGIS as shown in the figure. Here, blue color shows the sea area, green color shows the land area, and the red thick line shows the shoreline. All the shoreline are digitized as a line feature and are stored in a personal geodatabase using editor toolbox. As per DSAS specification, each shoreline has attributes such as an object ID, shape, date, uncertainty, and shape length. By follow this procedure, the shoreline of 1997 and 2014 are digitized and are shown in the figure. Moving to the quantification of the shoreline. For this, the extracted shoreline is projected into the UTM coordinate system and exported to the DSAS for analyzing. By using DSAS software, we can compute the rate of change of statistics for the time series of shoreline position. For this, a baseline is constructed and it serves as the initial point for all the transit. The statistic tool evaluates all address and the nature of the shoreline dynamics and trends in the shoreline changes. To display the statistical calculation output spatially in ArcMap, the statistic table has to be joined to the transit feature class by the transit ID field, which has the same value as the object ID in the field transit feature class. The computed transit are clipped with the shoreline change envelope, and this created a copy of the original transit clip of SC extent. Now, result and discussion. The rate of shoreline change is quantified by using endpoint rate statistical analysis method in DSAS. The shoreline change is thus found for the period from 1997 to 2014 as shown in the figure. From the attribute table obtained after statistical analysis, it is found that the maximum change in the shoreline due to the erosion occurred at Vadanapalli with a magnitude of 726 meter and Kurikuri with a magnitude of 94 meter due to accretion. Other critical areas are Engadiur, Artupuram, Kara, Arikod by erosion, and Palpatti Pokali shows accretions. The line feature layer of shoreline is converted to the KML file and is given as an input of Google Earth. Thus, the shoreline change estimated using DSAS is compared with the actual condition during 97 and 2014. The shoreline change occurred at Kara during 97 and 2014 are shown in this figure. For visual comparison of the shoreline change and its inward movement, the shoreline of 2014 is inserted as a red line in the left figure. The shoreline change occurred at the Vadanapalli during 97 and 2014 is shown in this figure. The accuracy of extracted shoreline from the satellite imagery is verified using the actual shoreline position collected from the Coastal Engineering Field Studies Department. The accuracy is checked using the shoreline change envelope and found out that the accuracy level is 90%. Moving to conclusion, the shoreline did change drastically in the steady area over last 2 decades. The maximum change in the shoreline due to the erosion occurred at Vadanapalli with the magnitude of 726 meter and at Kurikuri with the magnitude of 94 meter due to the accretion. Other critical areas are Engadiur, Palpatti, Pokkali, Artupuram, Kara and Arikod. Curved portions show a irregular pattern in the shoreline change. On close examination, it is found that straight reaches are less vulnerable to the shoreline change than curved area. Thus, the result obtained from this study will be definitely useful for the policymakers and coastal managers for evolving a sustainable coastal protection plan to safeguard its natural integrity and coastal resource. This study also ensured the potential of satellite image change detection study for terrestrial features. These are my references and thank you.
The session is open to the chairs for questions.
Hello, Ms. Amrita.
Yes, sir.
So your study is mainly on shoreline change detection of
Yes, sir.
Kodungallur region in Kerala. So is there any specific assumptions are there in your study? Whether you have got any assumptions?
No, sir.
No assumption. Okay. So how do you say that your shoreline is this one? What is the basis of the shoreline which you have taken, that whether it is accretion or erosion?
Uh, from the satellite image, Biden supervised classification. First, they classified the land and
That I agree. You are classifying all those things. You are classifying, but when you want to say that there is an accretion or there is an erosion, there should be a coastline should be defined. Somebody define it. So I should define my coastline first. Then only I can say that whether it is accretion or whether it is.
sir, in 1997 shoreline I selected, and from this I done the
shoreline. From where you would select it?
From the image only.
From the image. But why don't you go for a shoreline that is actually defined by the department? The department itself has got a shoreline definition is there. They have the coordinates and all those things. Why don't you go for with that one? You have not gone for the study.
Sir, I checked this work accuracy with that. Finally.
With 87, so 87 shoreline you have taken. So another thing is 87. What is the period of your data? Satellite imagery. Which month?
97 MSS image is taken.
No. 87. You are told 87 is the basis. 87.
97, sir.
97. Okay. 97. Then which month data is there? Which month data?
I think it's.
You don't remember.
Sorry, sir.
What about the other one? 2000 in the last year.
Same month is taken. 2014 and 97 same month is taken.
But there are different coastal disturbances.
Sorry, sir. Sorry to interrupt you. Next session is starting at 30, sir. We have one more.
We'll go. Yeah, okay. So, okay, then you have to press up. So what happens is, so you have to have a baseline that is to be defined. That I think there may be some error which will be coming due to that.
Okay, sir.
Also, that you have to check that one. Okay, so that may be, so you cannot say 100% because the shoreline itself is changing from season to season also. One season you may have accretion, certain region. I do not know whether this region which has got that one. Certain regions has got accretion in one season, in the monsoon, in the non-monsoon it has got erosion. That way it will be there. So, okay.
Thank you, sir.
Okay, so please check that detail. So,
okay, sir. Thank you, sir.
Hello, Dr. Suma. You can ask. I have.
Hello, Amrita. I have only one question. Just want to clarify. That is, you mentioned that in Vadanpalli, approximately this 726 meters, like approximately 1 kilometer. Okay, that is seashore get eroded. Have you ever been checked whether this is occurred or not?
Yes, ma'am.
Verified.
I got the site and checked it. There are a road also get disputed due to this.
Okay,
problem.
so you manually checked or
manually checked, ma'am.
You manually
I got it.
Okay. Thank you. Thank you, ma'am.
Thank
So now the question is open to the audience. Question session is open to audience, please.
There is no time for audience now. I think you have to close it because immediately.
Okay.
Thank you, Ms. Amrita. Now we'll be moving on to our next presenter, Ms. Anjana Ramesh, paper ID 333.
Recording stop here.
I'm here to present my study on the topic Blue and Green Water Security Assessment of Karuvannur Watershed. Availability of fresh water is fundamental for the sustenance of life on Earth and it is critical to provide food security as well as safe drinking water to a rapidly growing population. However, fresh water is often limited in quantity and is vulnerable to human activities such as urbanization, agriculture, irrigation, etc. Also, the climatic and land use changes along with increased human demand put a constraint to water security on a global level. So, water scarcity occurs when water available is no longer adequate to meet the requirements of the ecosystem. Water scarcity is calculated as a ratio of water demand over water availability, and it is used as an indicator of water security. And the water security is defined as the availability of sufficient amount of water of good quality to boost all ecosystem services with a tolerable level of water related risk. Water security assessment is very important because it enables us to take proper remedies even before the situation gets worsened. So the water available can be classified in blue water and green water based on the mode of its availability. Blue water is portion of precipitation that is stored above or below Earth's surface. That is the water that is stored in rivers, lakes, aquifers, etc. Then green water is a portion of precipitation that is retained in the upper layers of soil and vegetation and returns to the atmosphere as evapotranspiration. That is, green water is a water which is mediated by plants. It is seen that in most of the earlier studies, only blue water was taken into account. This is because blue water is the one which is directly linked to human consumption. But green water, which is indirectly linked to human consumption, was often ignored. This green water is important for agricultural production. Therefore, an assessment without green water is incomplete. So, water security assessment using blue and green water concept is required. This gives a precise idea about the water security of the study area and also about the effects of human intervention on freshwater resources. The main objective of the study is to assess the water security of the study area in terms of blue and green water. The specific objectives are to set up the hydrologic model of the study area in ArcSWAT software, to investigate the temporal distribution of blue and green water, to calculate the domestic and groundwater requirement, and thereby quantify the water security in terms of blue and green water. Next is the study area. Karuvallur watershed, located in Thrissur district of Kerala, is selected as a study area. It lies between a latitude of 10 degree 15 minutes to 10 degree 40 minute north and longitude of 76 degree to 76 degree 35 minutes. This river originates from Western Ghats and the length of the main stream is 48 kilometers and it drains an area equal to 1054 kilometers square. This is one of the major rivers in Thrissur district and it provides drinking water to numerous panchayats in Thrissur district. It has an actual utilizable water resource of 23 million meter cube, of which net utilizable surface water is 509.8 million meter cube and groundwater is 103.2 million meter cube. Average annual precipitation in the study area is as shown here. This is a location map of the study area. Now moving on to the methodology, first step is the setting up the SWAT model for the study area. So, using ArcSWAT software, the study area is modeled for 3 different decades. That is 1990s, 2000s and 2010. Then the data inputs required are spatial data and temporal data. This is a DEM of the study area. It is obtained from USGS. This is an SRTM DEM of 30 meter by 30 meter resolution. This is a soil map of the study area obtained from Soil Survey Department, Thrissur. And this is a land use map of the study area for the year 2005, obtained from Decadal LULC, published by Government of India. This is a delineated watershed of the study area obtained from ArcSWAT software. Then, next we use SWAT curve for the sensitivity analysis, calibration and validation of the model. Calibration is performed from the year 2006 to 2008 and validation from 2009 to 2011. Now the calibrated and validated model is made to suit the conditions of the study area, and from the output of that model, from the output of the SWAT model, blue and green water available is obtained. blue water is obtained as a summation of water yield and groundwater storage, and green water as a summation of soil moisture and evapotranspiration. Next, we use crop maps to determine the irrigation water requirement. Data required are the soil map, crop data, soil data, and various meteorological parameters. It is used for determining the blue water demand. Then we use population data for calculating the domestic water requirement. Using the blue water demand, using the blue and green water demands and their availability, water security for the 3 decades are computed and compared. Now, blue water scarcity is calculated as a ratio of blue water demand to blue water availability. While calculating the availability, environmental flow requirement is also considered. This environmental flow requirement is obtained from Global Environmental Flow Information System. Similarly, green water scarcity is also calculated as green water demand by green water availability. So both the values are obtained from SWAT model. So when the scarcity value is greater than 1, it indicates that a place is water scarce. So if it is less than 1, it indicates that there is no scarcity. Then, in order to understand the significance of blue and green water scarcity, we calculate the total water security also. Total water security is calculated as a total water scarcity is calculated as a ratio of total water demand to total water availability. Moving on to the results and discussion. This is the irrigation water requirement. This is a comparison of irrigation water requirement over the 3 decades. This is obtained from CropVac, and the major crops considered for the study are paddy and banana. It is seen that it follows an increasing trend. This is the hydrologic. Next is the hydrologic modeling. This shows a comparison of observed and simulated discharges during calibration and validation obtained from SWATSA. It is seen that an R square value of 0.843 was obtained for calibration and 0.810 for validation. NSE value of 0.62 for calibration and 0.55 for validation. Then, this is a graph which shows a comparison of water security over the 3 decades in terms of the water scarcity values. It is seen that under the current scenario, water is both blue and green water is secure. But it is seen that it follows an increasing trend. So it indicates that indicates water scarcity in the near future. This is a table indicating the values of blue, green, and total water scarcity. It is seen that all follows an increasing trend. Then this is a seasonal comparison of water security over the decades. First one is the pre-monsoon. It is during the pre-monsoon season, and the other one is during the post-monsoon season. It is seen that in both the seasons, blue water is secure, whereas green water faces scarcity. These are the values showing the during the pre-monsoon and post-monsoon season. This is a seasonal variation of water security. So moving on to the conclusions. It is seen that even though the total water security shows a safer value, the assessing blue and green water security separately gives a different picture. It is seen that in most of the study period, both blue and green water is less secure than the total. This shows the importance of separately assessing blue and green water security. Then it is also seen that in the current scenario, both blue and green water is secure, but the trend analysis shows an increasing trend which indicate scarcity. Indicate that scarcity may occur in the near future. Also, The annual water security shows that under the current scenario, water is secure. But a seasonal, temporal analysis shows a different picture. It shows that blue water is secure in all the decades in both the seasons, but green water is scarce during both the seasons under the current scenario. This shows the importance of conserving and minimizing the use of green water. So, it is seen that green water scarcity shows an increase of 8.67% in 2010s compared to 1990s in pre-monsoon season, and it shows an increase of 68.22% in 2010s compared to 1990s in post-monsoon season. It is also seen that green water is less secure than blue water in most of the study period. This inference cannot be generalized because the study area, most of the portion of the study area comes under agricultural area. These are the references. Thanks.
The session is open to the chairs for questions. I kindly request the chairs to stay within the time constraint as we are already running late.
Okay. So Ms. Anjana,
Yes, sir.
so what you from your study it is seen that how the irrigation water requirement has increased over the period from 1990 to 2000 or 2010. Are you showing whether the agricultural requirement has increased?
Yes, sir. The agricultural requirement has increased. It may be due to the climatic or land use changes.
Land use changes. So are you confident that from where you have got that data actually? Is it from?
I have calculated the irrigation water requirement using CropSwatch software. CropSwatch
software, but you require the area actually. The area which is from the field actually. It's not directly, you cannot get it from the CropSwatch software. From where you got the area actually?
Sir, I didn't get the question.
No, area under irrigation or agriculture or like that. From where you have taken that reference data? Whether you have taken from satellite data or something, or whether have you taken it from a direct source from the departments or like
From the CWRDM.
CWRDM. So they have mentioned okay.
Yes, sir.
But that type of detail should be given. You have not mentioned anything where you got data and like that. So what happens for blue water which is having blue water and green water? So which one is having more scarcity?
Sir, under the present scenario, green water is more scarce.
So is it in par with other studies, or is it a different one which you see from only for this catchment?
Sir, it is this result cannot be generalized. This is just for this study area.
Okay, Professor Sumam.
Hello, Anjana.
Yes,
Only one point. Slide number 17. 17.
Okay. Miss, can you see?
Yeah. Okay. So this is regarding the resultant description. So irrigation water requirements.
Yes, miss.
The slope, you are comparing it from
I cannot hear you.
Okay. The front of the graph is sloping upward, right?
Yes, miss.
Hello. Okay, so if you are considering, if you are extending beyond 2010 to 2010D, okay, so that means have you ever checked whether this requirement is?
Miss, this is only a part of my study. in my study, in the other portion of my study, I have predicted for the future and found out the irrigation requirement for future also.
Okay, okay, that means this is
Hello.
now justified for other years.
Yes, miss, I have predicted for other years also in my other part of my study.
Okay.
Ah,
Thank you, Anjali.
thank you, miss.
Hello.
Thank you, sir. Thank you, ma'am. Thank you, Angela.
Thank you.
Then Amrita, mute your voice. Mute.
Hello. Is there any, sir? Can you give some conclusion remarks on this session?
Oh, okay. 1 minute. Due to lack of time, I will say one or two few comments and I will stop it. So, all the sessions were applications of applications in the field of applications with case studies, which is specifically in the field of water resources. So, one or two points which I want to mention is one is assumptions. Whenever you go for any study, you have to mention the assumptions clearly in the study. Do specific conclusions for the study, then going for general conclusion. Then understand the algorithm and use the software tools in a better way for the study. So that the studies will be beneficial for all the others. Okay, thanks.
I call upon Sina ma'am to deliver the vote of thanks.
Good afternoon, everyone. It's been a very fascinating and very engaging section. On behalf of the Seaside 2020 coordinates, I would like to extend my sincere thanks to Dr. Jayaraj PG and Dr. Sumam KS, who accepted our invitation to chair the session and manage the session very effectively. The inputs given to the delegates would be beneficial for them. I am absolutely positive this session is going to be of great knowledge to our students. Thank you, sir, and thank you, madam.
This marks the end of this session. Moving on to our next session, session 3.
Good afternoon, all. Welcome to the third session of ICE Test 2020. Hope previous session was an informative session. Now I call upon session chairs at SCMS College of Engineering and Technology. He is an expert in multisensory environmental monitoring and data analysis. He was instrumental in developing the first ever database of air